Hello, for lesson for introduction. Before introduction, first one is no heat or additive needed. Great for dairy, juice, and protein food. How it works? Let small particles like water through blocks bigger ones like fats and microbes. For common use, ultrafiltration and reserve osmosis, like concentrate milk separate ware. For microfiltration and nanofiltration, remove germs and clean liquids. Why it's good? It's good for like save energy, keeps nutrient, reduce waste. And my last one is looking ahead. Growing demand is pushing better, smarter membrane system.
Assalamualaikum, my name is Nuradamia Binti Hanizat. My metric number is J22A0241. I will present about my part, material and design consideration. First, membrane material. We have polymer like polytersulfan, polyvilladine, fluoride and polyamide. These materials are flexible, affordable and work well at low temperatures, which is crucial to preserve heat-sensitive nutrient in food product. Next, ceramic membranes, typically made of alumina or zirconia, are highly resistant to heat and chemical. This is great for filtering viscous liquid or juice containing suspended solid, but they are heavier and more expensive than polymer membrane. Finally, we have nanocomposite membranes. These are polymer embedded with nanoparticles like silver or titanium oxide. They offer improved mechanical durability, antibacterial properties, and antifouling capabilities, which is available for extending the lifespan of the membrane and reducing contamination risk in food processing. The next, membrane structure. First, most membranes have an asymmetric design, which means they have a thin selective layer on top supported by a porous support layer underneath. This design makes the membrane strong and efficient, allowing it to filter selectively while staying mechanically stable during process. Next, let's look at the different separation types. First, reverse osmosis. This membrane has the smallest pores, allowing only water and very small molecules to pass through. It's commonly used for water purification or juice concentration. Microfiltration. This process removes cell and fat globules from liquid, which is especially useful in dairy and juice calibration. Next, ultrafiltration. This membrane retains protein and bacteria, making it ideal for concentrating milk protein or removing bacteria from liquid foods. Lastly, nanofiltration. This process filters out sugar and dissolved salt, which is helpful for demineralizing liquid or reducing sugar content. So, by selecting the right membrane structure and process, we can achieve an efficient separation while protecting the quality of the food product. Next, operating condition. First, most systems use cross-flow filtration. In this method, the liquid flows sideways across the membrane surface instead of directly through it. This design reduces clogging and helps maintain a steady flow over time, which is important for consistent operation and quality. Second, temperature is a key factor. Membrane process usually operate at low temperature to protect sensitive nutrients like vitamin, enzymes, and protein. This is especially important for maintaining the nutritional value of food product. Additionally, running at lower temperature saves energy, which is crucial for large-scale production, where energy costs can be significant. Overall, by controlling flow and temperature, we can improve the efficiency and sustainability of membrane process in the food industry.
Hi, my name is Nuria Smith Nazaruddin, G22A0154. So, I want to present about my part, fundamental concept of membrane technology. Membrane technology is a method of selective separation using semi-permeable membrane to filter liquid material based on chemical properties, physical characteristics, or molecule size. It's released on pressure gradients to allow small molecule like water and solute permitted to pass out while blocking large molecule like protein, fat, and microbes retented. Membrane processes are widely used in the food and dairy industry, each with distinct pore size and application. Like first, microfiltration (MF) that removes suspended particle, fat globules, and microorganisms. And second, ultrafiltration (UF) screen protein and large macromolecules while allowing small solid to pass. Third, nanofiltration (NF) selectively removes salt and sugar useful for particle demineralization. Then, the last one is reverse osmosis (RO), offer maximum purification, rejecting almost all dissolved salts. So, for the process description, membrane separation is a pressure-driven process that utilizes transmembrane pressure (TMP) to selectively filter fluid components. Small molecules like water and low molecular weight solid pass out the semi-permeable and membrane as permeate, while large molecules such as protein, fat, and suspended solid and microorganisms remain on feed side as retented. This process enables concentration, purification, and clarification in food and dairy application. The membrane pore size plays a crucial role in determining while particle can pass up. Additionally, the membrane properties such as hydrophobicity, surface charge, and chemical compatibility influence separation efficiency. Operation condition like pressure, temperature, and flow rate also impact membrane performance. Higher pressure increase permeation rate by may lead to membrane fouling, while temperature affect fluid viscosity and permeability. Shear force, controlled by flow rate, help minimize fouling and maintain a consistent fluid. For the mechanism, the membrane process uses transmembrane pressure (TMP) to push fluid through a semi-permeable membrane, separating small molecules like water and solids limited from large ones like protein, fat, and microorganisms retented. The technique helps concentrate, purify, and clarify food and dairy products. Membrane selectivity depends on factors such as pore size, material properties, and operating conditions like pressure, temperature, and flow rate. Higher pressure increases filtration efficiency but can cause fouling, while temperature affects fluid movement. The flow rate helps prevent clogging and ensure steady filtration. Together, these factors optimize membrane separation, making it a reliable technology in food processing.
Membrane technology plays a vital role in modern food and dairy processing due to its efficiency and sustainability. In the dairy industry, ultrafiltration and reverse osmosis are commonly used to concentrate milk and wheat protein. A recent study by Skillful et al. 2024 showed that an ultrafiltration system achieved 95% solute rejection at just 2 bar, providing its effectiveness for high salinity feeds. Additionally, integrating ultrafiltration and reverse osmosis system allows dairy plants to recycle processed water, it significantly reducing the fresh water use and wastewater discharge, which support the sustainable operations. In vegetable processing, nanofiltration membranes have been used to treat and reuse wash water. For example, in a carrot processing facility, this approach that lower chemical oxygen demands and reduce overall water consumption. Recent innovations like nanocomposite membranes embedded with titanium dioxide and silver enhance the resistance to fouling and improve durability. Meanwhile, advanced module designs such as vibrating and spiral wound membranes optimize the flow and extend the membrane life. Overall, membrane technology offers high separation efficiency, energy saving, water reuse, and better product quality, and it's making it essential for sustainable food production. Next slide is challenge and limitation of membrane technology in the food packaging. One is membrane fouling, caused by a buildup of protein, fat, polysaccharide, and microorganisms. Reduce filtration efficient and requires frequent cleaning to hide her operational costs. One is flow deadline due to solid accumulation, new membrane surface contraction or polarization slow down the process and worsen fouling to require strict control of pressure, flow rate, and each other. Point is high cost and limited lifespan, high initial investment and ongoing maintenance. Some membranes are sensitive to heat and hard chemical to limit cleaning option. Next slide is challenge and limitation of membrane technology in the food packaging. One is membrane fouling, caused by a buildup of protein, fat, polysaccharide. I want to present for my part is recent advice and innovation. First is improve module design and smart membrane. First point is module innovative, designed by hollow fiber modules, vibrating modules, and sprinkle wine system. Benefit for module innovation is reduce membrane fouling, enhance hydrodynamic flow, and greater efficiency in separation. The next point is smart self-cleaning membrane, future to coat with stimuli responsive material, respond to pH change and temperature fluctuation. Outcome with automatic self-cleaning, maintain long-term performance and less manual maintenance. Next is sustainable and digital innovation in membrane technology. First is 3D printed membrane, highlight to custom, tolerate membrane geometry and improve flow dynamic and efficiency. Second point is waste valorization, focus to convert food byproduct into valuable material, example protein and polyphenol, and promote circular economy. And next point is AI and digitalization, smart picture, real-time optimization of process parameter and predict maintenance. Example is fouling prediction. And the last point is solar power membrane. Green advantage is use renewable energy for membrane process and reduce carbon footprint in contraction and separation. Third point is energy efficiency concentration method. First point is forward osmosis and membrane distillation. Key use ideal for heat sensitive product. Example is fruit juice and dairy protein. Kelebihan adalah low temperature process, preserves flavor and nutrient, and energy saving compared to traditional thermal method. Next is electromembrane technology. Function is selective ion removal in barrage processing. Kelebihan ialah enhance product stability and reduce need for chemical additive. And the last point is anti-fouling and adapting membrane solution. First is anti-fouling strategy. Technique is dynamic flow design. Example is wheeling and vibration. Pulse flow to disrupt fouling layer formation. Next is smart adaptive membrane, feature to stimuli and responsive behavior, reach to pH, temperature or light. Function dia adalah adjust permeability or safe clean under specific condition and achieve its fun and process stability.
Okay, for conclusion, membrane process have made food processing simpler, mainly when it comes to clarifying and concentrating items such as dairy, juice and vegetable. It supports informal canning which keeps food fresh and safe. Reverse osmosis, ultrafiltration, nanofiltration and microfiltration give advantage such as clearer separation, less wastage and energy efficiency. Even though membrane folding expensive system and poor durability and common issue, advanced technology and innovation are solving them. With the help of new developments, membrane technology will have a strong impact on sustainable and quality food production. That's all from me. Thank you.